output method in Java. So here we have println is an output method in Java. So we have to understand that Java consists of packages, and the packages consist of classes, and the classes consist of variables and methods, right? So we have to understand where this println method is present, in which class, and the same, the class is present in which package. Those things we have to understand, and we have to get object of the class. So first, println, whatever I'm explaining is already defined by a software developer. How it has been defined, I'm saying. So here println is a method of class known as print string. Means println is a method. Yes, I've started. Println is a method of class print stream, and print stream is a class present in a package known as IO. Java.io.print stream. So we said a lot of packages will be there in Java, but for basics you'll be seeing three packages: java.io.star. Star indicates all the particular classes. Java.lang.star and java.util.star. These are the basic packages which we'll be using. So here println is a method. This method is present in a class printstream, and this printstream is a class which is present in a package IO, java.io. So now we need an object of printstream, as it is a predefined class. For the printstream, already object has been created by the software developer. Means he has created a object of printstream in a class known as system. So what is the system? Is a class which contains the printstream object, and this class is present in a package known as java.lang. And here you can see that print stream has an object, or you can say it's a reference out, where this out is a part of system class, right? Now if you want to access out, I need object of system class because there is no memory for system. But if it is static, means if this print stream out is static, then it doesn't depend on object, it depends on class name. What is the class name? System. So how to access this out now? By system. So system dot out, and this out is an object of print stream. You can say static object. So this out can be used to call the method println of print stream class. So that's the reason we are saying system.out.println. And here println is a method, out is a static object of print stream which is present in system class, and system is a class which contains the print stream object. That's the scenario. The same thing I'll show you in the command prompt also. Like if you want to check what are the methods present in a class, we have a command known as java profile space java dot io dot print string. So here what will happen? Here you can see what are the methods present in print string class. So from now onwards you have to see this command every time when I am using a method or a class. You can cross verify that. Okay. So here we have a method known as println. This is the method. So to call this method, what we have, we need an object. So java p space java dot lang dot system. System is a class which contains print stream object. If you see here, the system class has a print stream object out which is static, and static means it depends on class name. So I can use system dot out, and the system dot out dot println. That's the first thing you have to understand. So there is a output method in Java. And what are the classes I am using? I am using a system class. So if you want to import the package, you can import java.lang.start, because whenever you want to use a predefined class, that particular class package must be imported. But in this scenario, if you don't import the package java.lang, then also compiler will not give any error, because there is a default package which is being imported by the Java compiler. The default package is nothing but java.lang. Means the note point, you have to understand that by default java.lang package will be imported by the compiler. So it's based on the requirement. Other classes if you are using, then you have to import them. It's mandatory. Okay. But if you're using any class from lang package, you no need to import this particular lang, because compiler will be importing on behalf of you. Okay. So this is the output method in Java. I'll just repeat this once again. It's nothing but, in Java we have methods. That method is present in a class. The class is present in a package. So println is the method which is present in a print stream class, and the print stream class is present in a java.io package. For this class, already the object has been defined in a class known as system, which is out, and this print stream out object can be accessed because this is static, so it can be accessed directly by using system. So system dot out dot println is the output method in Java. Okay, so the static term can be used everywhere, because if you don't have any object, you can use the static. Now, is it clear or any doubts? If you have any doubts, you can message me. So next, after the completion of this output method in Java, we'll see what are the types of variables in Java. So here, the next concept is types of variable. There are two types of variables. That is primitive variable. Second is object variable. So what are the examples of primitive variable means? It's nothing but, if I say int a, that a is a primitive variable, and if I say test T equals to new S. T is an object variable. So there are two things will be there. But as primitive variables, if you see here, can again be classified into three types. Means based on declaration, the primitive variables are classified into three types. Like how we are declaring them, based on that it has been classified. Like consider here, first it will be instance variable. Second, it will be static variable. Third, local variable. So these are the three types of variables you can say. So what is instance variable? That we have to see. Consider I am writing an example. I have a class student. That student class consists of two variables, int id, float percentage. We know that class doesn't have any memory, right? So this id and percentage doesn't have any memory. So the instance variable is nothing but if a variable is declared inside a class and outside a method or a block or a constructor, that variable is known as instance variables. What is a block? What is a constructor? It will be clear in the future class. And here you can see we have written int id and float percentage inside a class and they are outside a method. Then we can say these two variables are instance variables. Now what is it? This instance variable depends on object, means there is no memory. If you allocate or create the object, then a copy or a location will be generated for this int float, two data types. Like for example, for a student, if I am creating an object, like here I am creating an object known as Rahul. So Rahul will have an ID and percentage, right? So in this memory block, we'll be having the space for ID and we'll be having a space for percentage. ID and percentage. And if you see, for one object, one copy of instance variable will be generated. Like one location of ID and one location of percentage. So here, if I create one more object, then one more copy will be generated. If I create one more object, then one more copy. Means for n objects, n copy will be getting generated. So what do you understand by that? Instance variable scope is entirely depending on object. Like if I create an object, a copy will get generated. And if I destroy the object, copy will get destroyed. That's the point. So here you have to understand that memory is getting allocated or creating an object means we are allocating some space. That space is nothing but in JVM we have 5 memory blocks. What does the 5 memory block means? First is method area. Second is heap area. Third is stack area. Fourth PC. And the last native area. So here if you see the JVM has 5 memory blocks and when I create an object among these 5 the heap area occupies the objects. Means whenever you create an object the memory is getting allocated in heap area itself, and it won't occupy any other memory. That you have to understand. So here every object is created inside heap area itself. That's the first point. Now here int id and float percentage, two variables are there. I haven't given any values to them, right? If I print this id and percentage, then default values will get displayed. That is, when programmer is not assigning any value to a variable, then default values will be taken. For example, here the default value for int will be 0. Like here, int it will be 0, and for float 0.0. For string it will be null, and for boolean it will be false. So what we have just seen is a concept known as types of variables. In that, instance variable is the first concept, where a variable is declared inside a class and outside a method is known as an instance variable. For example, id and percentage are instance variables, and this instance entirely depends on object. Like for one object it will generate a copy of instance variables, and for n objects n copies will get generated. The total scope is depending on the object itself, and the memory which is getting occupied is nothing but heap area whenever we create an object. And along with that, if you don't specify any values, then default values will be taken. Like for int it will be 0, for string it is null, and for boolean it will be false. This is the entire instance variable concept. Okay, so once you complete this instance variable, the second concept is nothing but static variable. When you already have an instance, what is the purpose of static? That you have to understand. Now, any doubts till now? If you have any doubts, you can ask me. Next, static. Suppose, consider I'm having string college. The string college is declared inside a class and outside a method. The college, you can say it is an instance variable. So for every instance variable, a copy will be generated for every object. Consider I'm having n objects. In here, in a class of 60 students, for the 60 students, the college name will be same, right? Suppose consider I'm having CMR. Means here this college CMR is same for all the objects whatever we are creating. Like suppose here Rahul object has college CMR. In the same way, n object has the college copy, and which consists of the value CMR. So what we are seeing here, that college CMR is occupying the space a repeated number of times. Means here wastage of memory is happening. So in order to save the memory, the only reason why we are using static is nothing but to save the memory. Like for a variable whose value will be same for all the objects, those type of variables we have to declare it as static, because static doesn't depend on object, it depends on class name, and for the static variable only one copy will get generated. Means in this scenario, if I declare string college as static, there will be only one location for the static which is common for all the objects and which is available to all the objects. So here you have to understand that even though it is a static variable, the static variable is available for all the objects and for all the students. You can see this value, whatever you have in this college, will be same. Like for example, in a class of 60 students, the college name is CMR. Suppose consider another college is there. In that class, for those students, the college name will be same. Means if I change the value of static variable college, the same value will be applicable for all the objects. Means it will be same for all the objects. So here static means only one location. That's it. If you want, you can change the value also. But whatever the value you are changing, that value will be same for all the objects. And here, if you see, previously CMR was there. Now it's MVSR, which is common for all the objects. So what is the first thing you have to understand? The only reason why we are declaring a variable as static is to reduce the memory. Means here if a variable has same value for all the objects, instead of going for instance variable, we can go for static variable, as static occupies only one memory or only one copy is generated. And here whenever we are declaring any variable as static, the memory is occupied in method area because it doesn't depend on object. So you can't store static variable inside a heap area. It will be stored inside method area itself. As I said, there are two kinds of memories. One is object, one is static. For static, there is a separate memory area known as method area, and for objects, it's heap area. And for the static variables also, if you are not assigning any value, then default values will be taken. Like for example, here int 0, string null, and boolean false will be same for static variables also. That's the second point. Okay. So now after static variable, we have one more thing known as local variable. So here you have to understand. Just give me a second. So what is the next thing? Types of variables. So here primitive variable, instance variable, and static. If you see, college student ID and percentage are instance, and string college is static. For ID and percentage, the value will be varying from object to object. Means from student to student, the values are different. Whereas for college, it will be same for all objects or all students. For that reason, we are declaring the college variable as static. Means a variable whose values doesn't change from object to object is declared as static. That's the only thing you have to understand. And if you see the local variable, A variable is declared inside a method, block, or a constructor is known as local variable. It's nothing but if the method is getting executed, the memory is allocated for the local variable. And when the method is getting completed, the memory will get destroyed for the local variables. And the scope is entirely based on the method. And for local variables, the memory is allocated in stack itself. So here for instance, the memory is allocated in heap area. For static, the memory is allocated in method area, and for the local variables, the memory is allocated in stack. And the most important point here would be if we are not initializing the local variables, then compiler will give error. We'll see an example for this because here only for the instance and static the default values are applicable, whereas for the local variables it's mandatory to give the values. This is a basic mistake a lot of programmers will do. Try to remember that for local variables we have to assign the value. Okay, so just now we have seen instance, static and local. For that we'll see an example. In this example I'll just show you what is instance and what is static. So class student, the same example I'm taking here. Int id, so this is instance. Static string college, so this string college is an static because we are using the keyword known as static itself. Okay, so next here I'm writing one more class for public static void main. Understand this, according to the standards, whenever you write a public static void main, you write it in a separate class and you try to assign that class as public, because when you declare that class as public, the rule we have to follow is that file name and class name must be same only when the class is public, right? So here I am just giving a class name as demo, right? So here there is a class name as demo, and see this, whenever you write a class, open a flower bracket and close it here itself so that it will reduce the errors. Now if I'm writing a method public static void main string args, then open the flower bracket here and close it here itself so that there won't be any confusion. Next, the first thing what we have to do, instance depends on object and static depends on class name. Means here college is a static which is depending on student, and id is an instance which is depending on the object of student. So here just we have to create an object for student. Rahul equals new student. So when the new keyword is getting executed, the memory is allocated for student class, and now the memory is allocated in heap area itself. There is no value for id, right? So I can access the id variable only with the Rahul object, because in Rahul only we have the memory for id. So here the dot differentiates the object and the variable, and we are giving a particular value like Rahul dot id is 1023. Next, after that, the college can be accessed by using class name student dot college equals to the string value is given in double quotes. I am giving it in double quotes itself. In order to print these values, we have to use the output method println. So how to print that? System dot out dot println. In that, what you can write? Rahul ID is plus. The plus is a operator which differentiates the double quotes and the variable. So here the variable is ID, but you can't access the ID without object. You have to understand two things. In Java, either you use instance or either use static. So here whenever instance is there, then left side object must be present, and that object is differentiated by dot. In the same manner, whenever you have static variables or static thing, that static doesn't depend on object, it depends on class name. So every time you should have a class name besides the particular static, okay, and that is differentiated by dot. So either an object or a class name must be present. You can't write that variable ID directly. If you write like this, it will give error saying that it can't find the symbol ID. So you have to understand that you call it only by using object. So what is the object here? Rahul. And what do you mean by object? Object is nothing but a memory block. So here Rahul is a memory in which ID has a value known as 1023. And now system dot out dot println. Here in this, the college name equals to plus student dot college, student dot college. Now here I am creating one more object, like student Kiran equals to new student. So here Kiran is an object and I'm not assigning any value for ID. So here Kiran ID, I'm just saying Kiran ID plus Kiran dot ID. Now again I'm printing the college, system dot out dot println. What is it? College name equals to plus student dot college. That's it, right? Now I have to save this program. I'm saving it as demo because the class is declared as public. So in D drive we have a folder known as programs, right? In this programs we have to save it as demo.java. If it already exists, just I'm replacing it. Okay. Now tell me what will be the output here in this program. We have 4 printlns, means totally 4 values will get displayed. One is rahul.id. So now tell me what is rahul.id, what is kiran.id, what is student.college. 2 times. Just message me
Rahul
this
dot
answer.
ID will do.
Everyone. What are those values I want? So here what value will get displayed? So first 1023. Okay. Next. Here CMR will get displayed. Next. What is Kiran.id I want? Yeah, but first what is Kiran.id? So here in Kiran.id we haven't given any value, right? So default value will be taken, that is 0 for integer, and for student.college what will be printed? So here for student.college, is it null? Try to understand the concept that For static, only one copy is getting generated. When you generate a copy,
Oh,
when you have already assigned CMR, then already the college variable has CMR value. So when
yes.
you again use a student.college, it will print CMR itself.
Double thing.
That's the most important thing. That for object, whenever you create a memory, a copy will get generated. And for static, only one copy will be there. And whatever the value you are assigning, the same value will be there for all the objects. The same thing we'll see in the output. Like here in D drive, cd space, programs, and this Java C space. What is it? Demo.java is a file name, and Java space demo is the class name. So Rahul ID is 1023 and college name is CMR. Kiran ID is 0 and college name is CMR itself because college is static. As I said, when whatever the value you are having, that value will be common for all the objects. Irrespective of the object value, that static value will not change until unless the programmer is trying to change it. Okay, so this is the important concept. And as I said that JVM has 5 memory blocks. So we should know what are those memory blocks, right? Already we have seen that. One is method area, heap area, stack, PC, native area. So the stack area is occupied by local variables, right? So we'll see what is JVM architecture actually. So we have JVM architecture. In this JVM architecture, you'll be seeing that entire memory blocks. What are the memory blocks we have? So if you see here, this entire architecture is of JVM, Java Virtual Machine, which executes our program. So the method area entirely consists of static variable, static block, and static method. It occupies only for static. And for heap area, we can only occupy for instance variable, instance block, and instance method itself. And the stack area occupies the memory for local variables. Okay. Now there is a scenario. Here Java C space test. Here we have Java C space test dot Java, right? So what is it? A dot Java file. In our scenario, it's demo dot Java. So when you give Java C space test dot Java, a dot class file is getting generated. This is the dot class file. Now, where is this particular dot class file present? It's present in hard disk. Like if you see here, when I open a particular D drive, just closing it. Just give me a second. So this dot class file is present or generated in hard disk itself. So if you see in D drive, this particular programs folder, it will be getting generated, right? So in this programs folder, we have this demo.class file, right? It's in hard disk. Now For every dot class file, the memory gets allocated in the RAM. So first thing, we have to shift this dot class file from hard disk to RAM. Then how we are doing it? By using this step, when you say Java space test, then the dot class file is taken and given to a particular class loader here. And this class loader, what it does, it takes the dot class file from hard disk and it will just shift this dot class file from hard disk to RAM. In that RAM, it will just place the dot class file inside the method area itself. And here, when you just shift that particular class from hard disk to RAM, at that moment the memory will be allocated for the static variable. Means the scope of the static variable depends on the class loading and unloading. So loading means shifted from hard disk to RAM. Unloading means again you are removing it. So the scope entirely depends on the class. Okay. And whereas the scope of static is nothing but when object is created, then copy is getting generated, and when the object is destroyed, copy is getting destroyed again. Okay. So here, after the method area, heap area and stack area, you have PC and native area. So what is PC means? Program counter. You just have the number of instructions per program, whatever we need. And you have to understand that the most important things we need to understand about is only method area, heap area and stack area itself. Whereas the native area is nothing but if you are using any method which is declared as native, then that particular method occupies in native area. And what is native? We'll see in the future class. Okay. Till that time, remember that the native methods occupy inside native area, and for that interface and library files are also provided for support. And one more thing, the JIT is nothing but Java just in time. Like JIT means just in time compiler and interpreter. Both these things convert this bytecode or machine code, sorry, bytecode into machine code and give it to the OS. Okay. So this is the entire thing JVM architecture consists of. And that's it. This is the end of the JVM architecture. We have seen types of variables, output method in Java, and the JVM architecture. Okay.